Afternoon to all. I, Unnati Shah, working as an assistant professor in Electronics and Communication Engineering Department in Parul Polytechnic Institute, Parul University, Vadodara, Gujarat. Welcome to all in today's webinar about basic industrial automation. Today's speaker is Mr. James V. Maisuria. He is working as an assistant professor in Electronics and Communication Department at Chotubhai Gopalbhai Patel Institute of Technology, Uka University since 2013. He has completed his bachelor's in Electronics and Communication Engineering from C.K. Pithawala College of Engineering and Technology, Surat. He has completed his Master of Engineering in Wireless Communication System and Networks Engineering from Government Engineering College, Surat. He is pursuing his PhD in his research area of Cognitive Radio Wireless Sensor Network. Currently, his area of interest is networking, WSN, embedded system, and automation. He is also in charge of PLC laboratory at Maya Talsaria Industrial Automation Research and Development Center at Uka University. He has also given industrial PLC training to NPCIL engineering scientists. He is a stream member of MBA NAC Committee, Purchase Committee, Project Coordinator at C.G. Patel Institute of Technology. He has also completed 2 industrial automation projects for companies, Himson and Tapco, USA. He has given more than 10 expert talks on industrial automation in various colleges. His team has designed an online certificate course on industrial automation with PLC to guide research students and industrial persons. He guided total 25 group of UG students for project, and also under his guidance 8 MTech student has completed that postgraduate degree in electronics and communication engineering. So welcome sir, and without wasting much time we are starting our session. Over to you sir.
Thank you very much for this much introduction. As Unnati madam is my colleague with my HAMTech, so I also thank you to them. So without wasting much time, we'll just start our webinar. Okay. So before starting this webinar, I'll just want to show you 2 or 3 videos related to this industrial automation, and that will just give you that motivation for this particular webinar. Okay, so wait for a minute. I'm just sharing a screen. So basically this video is related to the industrial revolution or industry 4.0, which is developed by the Siemens company.
A vision of tomorrow's manufacturing. Products finding their way independently through the production process. In intelligent factories, machines and products communicate with each other, cooperatively driving production. Raw materials and machines are interconnected within an Internet of Things. The objective, highly flexible, individualized and resource-friendly mass production. That is the vision for the 4th Industrial Revolution. A look back at history. At the end of the 18th century, the first steam engines and the intelligent use of hydropower revolutionized production. The late 19th century saw the rise of electrical engineering and mass production. The first moving belt conveyor was used as long ago as 1870 in the slaughterhouses of Cincinnati, Ohio. In the mid-1970s, electronics and IT began to expand rapidly into industry. Siemens developed the first SIMATIC. Production became increasingly based on computer-assisted controls. The 4th Industrial Revolution is still a vision. Experts believe that it will only become a reality within the next 20 years. In intelligent factories, everything is interconnected wirelessly. At the German Research Center for Artificial Intelligence in Kaiserslautern, this future can already be experienced right now. Research is underway here into exactly what the industrial production of tomorrow will be like. A bottling plant for liquids, set up together with Siemens, is used to demonstrate the most important components of the intelligent factory of the future. Each bottle contains an RFID chip storing a precise description of how it has to be processed, which liquid, which lid, and which label. At each station, the bottle communicates directly with the machine, telling it how it has to be processed. At the end, a computer checks whether the bottle has actually been produced as desired. Factories with networked machines and products are already in existence today. In the future, however, these hitherto self-contained systems will be connected together in a comprehensive network. All devices, machines, and materials will be duly equipped with sensors and communications technology and connect to each other. These systems are known as cyber-physical systems. The highlight is that they communicate with each other and also control each other cooperatively. For the customers, this means tailor-made products at relatively affordable prices. For industry, it means highly flexible mass production that can be rapidly adapted to market changes, because in the future, product life cycles will be even shorter. Another reason why it's increasingly important to depict engineering across the entire life cycle. Maintenance, for instance, is planned in from the very start. At Corporate Technology in Princeton, a cyber-physical control is being researched even today. The vision, the control, and all linked sensors are connected to the internet.
One potential scenario is enabling the PLC to react to utility pricing information in building automation. We can enhance PLCs to use simulation to calculate how much to pre-cool a building, with the ultimate goal of turning off the cooling system during peak times.
But that's just the beginning.
We've prototyped capabilities in a PLC to access big data in cyberspace in real time. And we've also enabled a network of PLCs to connect to a dynamic simulation of the entire physical process.
Siemens is shaping the future of industry. Connecting the real with the virtual world of production is making it possible to enter entirely new dimensions in quality, efficiency, and flexibility. The company is well prepared for Industry 4.0.
So this is related to actually that
our world is interconnected. The Internet of Things and Services allows for limit.
So actually this one, whatever the video we have seen, that is related to the industry revolution. There's one more video that is from the boss Rexroth from the Germany. So I'll just show you this video that how smart factories are developed.
Less possibilities. New technologies expedite the creation of revolutionary value-adding innovations. What seemed like yesterday's science fiction is today's reality. The fourth industrial revolution is at full speed. As pioneers of this new era, we at the Blachach plant operate a standardized production network worldwide. Our strategy is geared towards a digital factory. Our hydroelectric power station generates renewable energy. By combining energy and production data, we systematically improve our energy efficiency. Our digitized in-house special machine building unit paves the way for a fully connected production. The interaction with our machines is as intuitive as using a tablet. We experience our machines throughout the design and construction phase. To achieve this, we make use of virtual reality. Our holistic strategy towards a digital factory ensures the utilization of future-oriented technologies. To this end, we develop processes that will shape the world of tomorrow. The complete automation of our flow of material through RFID streamlines our logistic processes and reduces stocks. Simultaneously, we create transparency along the entire value stream in real time. We're aware of the processing status of every order at any given time. This fosters a highly flexible environment. Furthermore, demand-driven material replenishment reduces the workload of our employees. In our relentless effort to improve, we utilize automatically generated analysis and evaluations. In doing so, we can focus on what's important: the availability of our machines. Failure losses on production lines are made transparent by means of standardized visualizations and address specific target groups. This facilitates a comparison and benchmarking of our machines on a global scale. Trends and critical developments are automatically detected and reported to our operating personnel before output losses occur. We record potential error sources. Relevant video sequences are intelligently edited and subsequently analyzed. Reoccurring interferences are linked to known error patterns. Recommendations for action are derived from these patterns and enable our personnel on site to act as skilled problem solvers. Industry 4.0 also represents flexibility for our employees. Mobile shift scheduling allows a quick and customizable shift organization. In our cafeteria, we experience the advantages of digitization on a daily basis. RFID technology improves the payment process and caters for a relaxing lunch break. Our success is based on the exemplary collaboration within our network of experts. In all of this, we pursue one clear objective: ensuring the future of our plant and thereby the future of our employees. Because there are some things you simply cannot digitize.
So this video is related to actually how that industry 4.0 was developed in Germany. Okay. Now the last video, that is the demonstration of particularly the model which is available at our university. That is nothing but a mechatronics model. It's a small version of your you can say automatic bottle filling plant, but it's not a bottle filling plant, but it's a cube making model. I'm just playing that. Okay, so that's it. So as you have seen over here in the last video, so it is a module or a model which perform a cube making, as well as then after it will just pick and put that particular uh, cube to that particular storage place. Okay, so we have used over there automation. Okay, actually it's not a industry 4.0, because when we talk about industry 4.0, then in industry 4.0 you have to combine internet with that. That means the each and every devices will talk with each other through the internet. Okay, so that we will see, and we have seen the same thing in the first video also, that what is the industrial revolution. Okay, so this 3 video, I think so it will motivate you for this particular automation field. Okay, so you have seen that how this particular automation is going on. Okay, and we have seen some of the you can say shows in discovery that will show you the smart factories. So you can see that videos on your Facebook, or you can say on YouTube also, that how that particular industries are changing from that particular manual version to automated versions. Okay, so this is at our Uka Tarsaria University, one of the center, Maya Tarsaria Industrial Automation and Research Development Center. Okay, so we'll start with the particular learning sequence. So we'll see the industry revolution, PLC, the history of PLC, and then after we'll see the remaining parts if we have a time left. Okay, so what is industry revolution? So as we have seen in the previous video, we are just improving our industry, machine made and a large scale factory. So that is nothing but your industry revolution. Okay, so the example of that is nothing but what? A textile production, which is shifted. We are before over here in the Surat, we are just making this particular textile material, clothes at the home, and that will be shifted to the factories and with the automations. So we have seen this first industry revolution. That first industry revolution is nothing but what? It's operated on steam engine. So before industry revolution 1.0, or the first industry revolution, all the peoples are doing this production and transportation related work, that is through your human or a animal. Okay, so we are using that human or animal power for transportation as well as production. Then after, we have just introduced this steam engine. So steam engine is introduced in the 18th century, between this 1760 to 1784 in the England. So what we have done, we have developed a mechanical device which will operate on the basis of the steam and the water, and will just produce or will just transport our whatever the goods or anything else through that particular machine. Okay, so that was actually started in the textile industries first. Okay, so we have shifted skilled based manufacturing to the mechanized manufacturing. Then after, the second revolution will be there, and that is nothing but your industry 2.0. So industry 2.0 is basically based on the electricity, and the main thing is not electricity, but the main thing is the transportation of electricity. Okay, if we don't able to transport our electricity from one place to another place, then what we have to do? If you imagine the world, then you have to generate that electricity from a steam engine. Okay, at each and every place. So think about that your home, it's having a television. So that television, with television you have to attach a steam engine. So that steam engine will generate electricity, and then after it will be provided to your television, and then you can watch a TV. Okay, so that is not there because we have a technique to transport the electricity. So that is the second revolution, or you can say industry 2.0, which is the industry based on the electricity. Okay, so that is in the 19th century. Okay, and we have shifted from that particular mechanized piece manufacturing to mechanized mass manufacturing. Means we are manufacturing in a lot of numbers. Okay. And then after your industry 3.0, and that is nothing but, as I have put this tagline, it's a magic of electronics. So in that duration, we have find out that electronics. So when you talk about electronics, the first thing which is come in your mind, that is nothing but a transistor. Okay, so all the electronics devices, whatever the integrated circuit, we are talking about VLSI technologies and other technologies, that is basically depends on what the transistor designs. Okay, so that in industry 3.0, we have just found out the transistors, and by using the transistors, we are developing what are different types of digital circuits, and that digital circuits are nothing but your controllers and processors. So using that controllers and processors, what we'll do, we'll start the automation. That means the human effort will be reduced, and we'll just start that machine will detect itself, and it will take the decisions. So that is nothing but your industry 3.0, and that is basically whatever we are calling as a automation. Okay, so the automation, whatever the devices or whatever the machines you are having in your industries, that will be automated using this electronics devices, or you can say this IT related field. Okay, so that will be started in the 20th century. Okay, and the first automation will be produced in 1940 by the Ford Motors. They are developing that vehicles automatically, the painting, then just assembling of that car, all the things will be done by automation. Okay, so that will be shifted from mechanized revolution to the digital revolution, because we are introducing now the digital circuits, or you can say the digital electronics over there. And then after your next industry revolution, which is currently going on, is nothing but your industry 4.0. So industry 4.0 is nothing but what? Add on into that particular automation. Okay, what we are doing now, each and every device, whatever we are having in our industry or in our home, that will be interconnected with each other. One of the ad we have seen in which Amitabh Bachchan will do that particular on and off of AC from the airport at his home. So that is nothing but what? You can say it's a revolution, IoT. Okay, so all the devices or things will be connected to the internet. So basically, that is in this particular 21st century. Okay, and you can say that was first started by the Germany, and then after it will be spread it everywhere. Okay, so it's a you can say it's a intelligent production. Okay, why it's a intelligent production, we'll see in the next slide. But that use big data analysis, cloud computing, and IoT, but we call it as a IIoT, that is industrial internet of things. Okay, so it will use a cyber physical system which will communicate between human and machine, as well as between machine and machine. Okay, and that shift or revolution is nothing but what? From digital revolution to cyber physical revolution, which will produce automated intelligent production. Okay, and then after, yeah, this World Economic Forum has just launched a fourth center in our India for this automation or a fourth revolution. It was first in USA, then Japan, and then after in China, and now it was in our India. That is a fourth center. Okay, and this particularly you can say industry 4.0 can be called as a smart factory in USA and industrial 4.0 in the Europe. Okay, so these are, you can say, the element or technology which are using in the industry 4.0. So as we have seen in that particular videos, okay, over there, this different technologies are already highlighted. Okay, so big data analysis is there, cloud computing, cyber security will be there, this horizontal and vertical integration will be there, robotics is there, augmented reality is there, additive manufacturing is there, simulation is already there, and IoT is there. So we'll see one by one each and every technology. Let's say IoT, you all know it's a buzzword nowadays. Okay, IoT is nothing but what? Internet of things. So each and everything, each and every device will be connected to the internet, and it will be communicate through the internet. Okay, so that is nothing but your IoT, and that will be helpful to communicate the devices with each other. Then after simulation, as you know, before doing anything, what we'll do, we'll just simulate and we'll just find out whether what will be the output of that particular simulation, or what will be the output of that particular process. So that is nothing but a simulation. So we'll use simulation over there. Additive manufacturing is nothing but what? Nowadays, you can say 3D printing is there. In one of Boss video, you have seen that, but a particular structure is made up of by that particular 3D printing. So that additive manufacturing is nothing but what? Before that additive manufacturing, what we'll do, if we want to design something, we'll take a block of material and we are removing material from that block and we are making a thing. Let's say we'll take one of the example of screw. If you want to make a screw, what you are doing, you are making a trade on that particular rod, and by that you are making a screw. So you are removing the material. Whereas this additive manufacturing, that means what? You are adding the material. So material wastage will be reduced over here in the additive manufacturing. Augmented reality. So that is nothing but we all aware about that AR. Okay. So you can visualize the virtual world over there. Okay. So how the machine will work, where we can operate that, all the things you can do with this augmented reality. Robotics is already there, because to pick and put, as well as anything you want to work, that will be based on robotic. Okay, now the horizontal and vertical integration is nothing but what? In a structure or in a machine, we are having what? Layers of machines. Let's say a supervisory machine is there, then downwards a different task machine is there, a sub part is there. So that is a layer between the devices. Okay, so over here with Industry 4.0, you can provide the integration of that particular devices. That top device will communicate with the lower device, in between also weather. So horizontal and vertical integration will be there. Cyber security is already there, because we are operating each and everything on an internet. So we require cyber security. Cloud computing and big data analysis is related to something when you want to take a decision. Okay, because when you connect each and every device with the internet, obviously you will get a number of data related to the sensing. Okay, number of particular reports will be generated. Okay, so that n number of reports can be analyzed by this particular big data analytics and cloud computing. So these are the technology which will contribute in this particular Industry 4.0. Okay, now the benefit, you can say mass customization. So nowadays we are doing in a car, when you're going to purchase a car, it will be customized by your requirement. Okay, let's say you want this color or you want something else in that. So that mass customization will be there with the Industry 4.0. Then after, flexibility of production, whenever you want to produce particular devices, or you can say goods, you can produce it. Okay, increase the production speed, yes, because all the things will be automated. Okay, high production quality and decrease the error rate, because machine is doing the thing. So whatever the input you have provided, it will be produced that way only. So error will be reduced. We cannot say that error will be avoided. Okay, but it will be reduced. Okay, advanced analysis will be there. Okay, so each and everything will be reported, so you can do the advanced analysis on that. Okay, because you can see nowadays the main problem will be the supervising. Okay, because in the industry, when you go for the visit of any industry, you can see that in each and every department you are having a supervisor. So that supervisor will take care of that particular section, whatever the missing thing is there, whatever particularly plant is working or not, all the things will be taken care by that supervisor, and that supervisor will report to the higher authority, whatever the manager is there, and then manager will be report to that particular CEO or whatever the person. Okay, so that way chain will be there. But in this advanced analytics, what you can do, all the reports will be collected by the internet, and whatever the analysis you want, that will be performed, and that will directly provided to the CEO on his mobile screen or laptop screen. Okay, so that is the benefit of this industry 4.0. And data driven simulation, we have seen that. Okay, predictive maintenance, why? Because we know all the things, that how this particular machine is working, what is the particular maintenance is required in that, so we can predict the maintenance also. Because nowadays some of the plant, if they just remain shut down for 1 day, then you can say in crores you will get a loss. Okay, so if predictive maintenance is there, then you can avoid that thing, shut down. Okay, and improve the work lifestyle. So that these are the benefit of industry 4.0. So summary of revolution will be there. Okay, industry 1.0, 2.0, 3.0 and 4.0. Okay, now need of automations in industries. It will increase the productivity, obviously, because you are reducing the errors. Okay, as well as the human errors also. Okay, it will increase the quality also, and it will reduce the cost. Okay, and as well as it will increase the safety in a working condition. Let's say we'll take one of the example, that boiler is there, so it may have a chances of blast over there, but if it is operated through machines only, then more safety will be there. Okay, now we'll just switch to the automation, because we are discussing on automation, that how automation will done. Then we'll go for the fourth revolution. So automation is nothing but we are just embedding that particular controller with our machine, and that controller will just take an input from the sensor, and then after it will just provide the actions to that particular actuators. Okay, so as the human, okay, human have sensors, okay, eyes, ears and skin, like that. Okay, so from that you are taking the input, and your brain will analyze that input, and then after you just provide output to your actuators. Now your actuators means human actuators are nothing but what? Hand and legs. Okay, so depending on that you are performing a work. So same way over here in automation also, you are having a sensors which will give you the input. You are having a brain, which is nothing but your controlling device, and this PLC or a processor or a controller, whatever is there. Okay, and your actuators. Actuators are nothing but what? Your pneumatic system, your hydraulic system. Okay, which will perform a work or a task with that particular machine. Okay, so first in automation we are doing a manual work, then pneumatic control will be given, then electronics control and the logic gates are introduced, and finally we have introduced this programmable logic controller. So what is PLC? So PLC is nothing but full form of programmable logic controller, and you can say it's a main part in the automation. Okay, because all the decisions will be taken over here only. Okay, so that PLC is nothing but it's a electronic device which will just get the input, and it will operate it according to that. So in that you are having arithmetic control, counting, sequencing, timing, and a different types of controls are there. As well as over there you are having digital to analog or analog to digital converters are there, and different kinds of input output modules are there. Okay, so it is developed by this NEMA, National Electrical Manufacturing Association, and it's also called as a industrial computer or a sequence controller, this PLC. Okay, so first this PLC was invented by this Modicon company in 1968. Okay, and it's replaced this particular hardwire relay panel. You can see in the photo that too many relays are there to control one device. Okay, so that all relays will be replaced by this PLC module. Okay, and in 1969 it was adopted by General Motors Corporation. Okay, and these are nothing but different companies which are making or manufacturing a PLC. So depending on our requirement, we can select the PLCs. Okay, so the first step in automation, as madam told you, that I have completed 2 projects. One is in Himson company in our at a station road in a Surat, as well as one is a USA based company, TAPCO company. So they have just given me a problem that I want a machine which will one machine will be you have to make a holes at a particular specific distance on a pipe. Okay, so they have just given me the problem statement, and they told us the particular you can say cost for that particular device. So based on that criteria, we have to select the PLC. Okay, so the main criteria will be what? The cost. So you have to select the cost effective PLC. Okay, programmable logic controller. So different makers are there. You can select any of the PLC. Different kinds of PLCs are also there. Okay, let's say fixed type of PLC, variable types of PLC. So that we'll see later on in the PPT, that which different types of PLCs are there. Okay, so as this PLC is replacing the relay logic, so we have to first understand what is relay. So relay is nothing but your electromechanical switch, which will just provide isolation between two circuits. Okay, so in that one coil is there and a contact is there. Okay, so when you provide input to the coil, what happens? It will just generate a magnetic field, and through that magnetic field, that contact will be attracted and your relay will be connected. So you can operate your device by providing input to the coil. You can see in the next PPT. Okay, so this is internal structure of that particular relay, and over here in particular this video, a small video, you can see, or a GIF file, you can see the working of PLC. When you provide supply over here to the coil, it will just introduce a magnetic field, and that contact will be attracted and your device will be operated. Simple. Okay, so this is a simple work of relay. Okay, so if you want to operate let's say n number of devices, you require n number of modules for this relay. Okay, so that a particular modules which is used as a n number of modules over there of a relay, that will be replaced by PLC. Okay, so that is the benefit of PLC, you can say. Okay, so the advantages of PLCs are that it's easy to program. You can program easily. We'll see how to program that PLC. It's flexible because you can change the programming anytime. More reliable, relatively inexpensive, because when you operate n number of devices, you require that much modules in the relay, whereas over here, by using one PLC only, you can operate that n number of devices. Okay, and it's have a capability to communicate with the field computers. Okay, you will just have to connect through the RJ45 or a serial port. Okay, that particular PLCs. But one limitation is there, that it's required a trained person to program that PLCs. Okay, so this is nothing but, you can say, the internal structure of PLC. So it is similar to our computer only, that we are having CPU, input output device, and you can say the power supply will be there. Okay, and one more part is there, that is memory, to store your program, and that you can connect with your computers. Okay, so these are nothing but the input devices, because different kinds of input devices are there. So selector switch is there, push button you can use for the input, proximity switch, binary encoders, barcode readers, photoelectric cells, limit switch. So these are nothing but, you can say, your digital inputs, whereas analog inputs are this flow transducer, potentiometer, temperature transducer, speed transducer. So depending on requirement, your requirement, whatever your requirement is there, based on that you can select any of the input device from here. Okay, so as I told you, that one of the particular automation related problem is there, that we have to do the holes at a particular location. Okay, so what we have to do, we required that particular location sensors. Okay, so based on that location sensors, we will get the input, and then after we can put the holes over there by using any of the device. Okay, then same way, the output device is nothing but your actuators. So motor will be there, light will be there, solenoid will be there, alarm will be there, different kinds of valves will be there, okay, relays will be there to control the high voltage devices, buzzers will be there, indicators will be there. So these are nothing but you can say the digital outputs, and analog outputs are nothing but the electric motors drives, okay, which is AC motors, okay, analog meters, DC motors are there, and servo motors are there. So these are nothing but your output devices. Now, as I told you that we'll see different kinds or types of PLC. So we are having fixed type of PLC. So that fixed type of PLC will be what? It's having a fixed number of input output. So the second criteria, as I told you, the first criteria to select the PLC is nothing but your cost. And the second criteria, which is for the selecting PLC, is nothing but you can select either a fixed PLC. So if you want to select fixed PLC, then you have to find out number of input and output will be required for your automation machine. Okay. Then after, the next one is the advanced version, that is nothing but modular PLC. So modular PLC will have a modules in it. Okay. You can see over here in the diagram that this blue modules are there and pink modules are there. So that blue modules are nothing but your input modules, and the pink modules are nothing but your output modules. And this black is nothing but your power rail, you can say. So if you want to provide the power to this modules as well as PLC, you can provide through that particular black modules. So different modules are there. So you can connect the modules and you can increase the number of input and output. So it's a variable type PLC. The number of input output you require, that much number of modules you can connect over there. Okay, so you can connect in a sequence. So that is modular PLC. So it's always better that you select modular PLC for your particular automation, but it little bit costlier. So if constraint is there in your cost, then you can go for the fixed PLC. Okay. So how the PLC will work? So as our computer will work, it will start the scanning first. A block diagram of your task and you are connecting it. Another one is your ST, that is structural text. So structural text means you are defining the structure in a text form. So it is similar to your C programming, Pascal, something like that, basic like that. Textual programming is there. And another one is your instruction list. So this is similar to your microprocessor. We are providing instructions, and according to that, your processor will work. So these 5 different types of languages are there for the PLC programming. Okay, out of that, we'll just see about the ladder diagram. Okay, so ladder diagram is nothing but, as I told you, it's a graphical or a symbolical representation. So in that, power rails are there. So left power rail, right power rail will be there. Basically, left power rail is nothing but a 24 volt, because this PLC will operate on 24 volt. Okay, and the right power rail is ground. Okay, and your power flow will be from left to right, and whatever you are connecting in between, that is nothing but a rung. Okay, so that rung will contain what? Your devices, or you can say your actuators and sensors. So one of the example will be something like this, that if you want to design a ladder diagram, it looks something like this. So this soft switch is there, start switch is there. Okay, this X1, X2, X3 are nothing but the sensors, and this round in a circle, whatever the X1 and M1 is there, that is nothing but your coils, relay coils or actuators, you can say. Okay, so according to that switches, this particular your devices will be operated. Okay, so first we'll see NO and C contact. So NO and C contact, we already know. NO means normally open, so it is related to switch. Okay, so when switch is not actuated, એટલે આપણે એને press નથી કરી, when we will not press that switch, what happen? It is in a normally open condition, and when you press that switch, means actuate that switch, it will be in the closed condition. So it look something like this over here. You can represent that switch by this way. Okay, two straight line. Okay, and whatever the output lamp, you can provide in the curly, or you can say this round bracket. Okay, so this way you can represent. And normally closed switch, that is nothing but what? Initially, when it is not actuated, it will be in the closed condition, and when you actuate that switch, it will come into the open circuit. So that arrangement will be something like this. So when you draw the ladder diagram, you have to draw something like this. Okay, whatever represented over here. Okay, so if you want to draw a open switch, so it will be something like this, NO. And if you want to draw the closed switch, it will be something like this. And then after, finally, the output, if you want to connect. Okay, so this way you can draw the ladder diagram. Okay, now this is not only the things when you do the programming. Some more that variables. So you can provide, it is similar to our any programming language, that if you want to provide the name, then different kinds of rules are there. So it not contained any special type of characters. Okay, and whatever the predefined blocks are there, that you cannot use, and you cannot use spaces between the variable name. Okay, and this is nothing but, you can say, a predefined name of the block, because when you going to program a PLC, that will depends on the software which is come with that particular PLC. If you take a PLC of Allen Bradley, then Rockwell Foundation will provide the simulation software or a programming software, that is nothing but CCW, Connected Component Workbench. So you require that software, and through that software you can do what? Programming of PLC. If you have this particular Boss Rexroth PLC, then you required IndraWorks Logic as a software to program that PLC. So different making or makers will have a different kinds of softwares, but they all follows DIN ISO standards. So that DIN ISO standards are nothing but what? Each and every will have a same representation in that particular software. Okay, so if T-on block is there, so they have a same representation of T-on block. So if you just learn about that particular programming of one type of PLC, that can be applicable to each and every PLC. So it's very easy. Okay, so now we'll go for the next. So that is nothing but, yeah, when you are going to just work with the PLC, then PLC actually will have input modules and output modules. So you can provide bit address to that particular inputs, byte address as well as, and a word address also. Bit address means what? One bit will be there. Okay, byte address means you can combinedly provide address to 8-bit, and a word means what? It's 16-bit simple. Okay, so according to your input, you can provide the addresses. If you are having analog input, then you can go for 8-bit or 16-bit, because that analog input will be finally converted into the digital one. Okay, so that digital one, depending on the resolution, you can provide the connection. So if you want to address a bit address, you have to provide this way a name, percentage IX. So this percentage will be the sign for declaring that particular address. I is for the input, X is for the bit, and this is the address. If different kinds of ports are there, so in that, this port 0 and a pin 0. Same way, this input, and then after this B for byte, and the whole port will be used. So port 0, port 1, something like that. Okay, and this is for the word. And the same way for the output, but for output we are using character Q. So this way you can provide the name or address to that particular variables. Okay, so now the basic circuits which we can develop in the PLC is nothing but this AND logic gates or logic gates, whatever the logic gates you can develop. Okay, so as we all know that AND logic gates will perform what? If your both the switches or both the input are 1 1, then and then you will get the output 1. Okay, so what we'll do, we'll connect the switch in a series. So when both the switch will on, it will give the output to this particular output coil and it will be operated. So it's a easy. Same way, OR gate, any of the one switch will be on, your output will be on. So we are just connecting in a parallel. Okay, so any of the switch will be on, you will get the output over here in the output coil. Okay, same way you can develop the different kinds of particular gates. Let's say NAND gate, NOR gate, XOR gate. Okay, so over here when we discuss about NAND gate, then the NAND gate will be over here. What you have to use? You have to use normally connected switch. What you have to use? You have to use normally connected switch in a parallel. Okay, so it looks something like this. Okay, so this normally connected switch will be there. This one is A and this one is B. So when it is not actuated, S1, S2, you can provide AB. Okay, so when it is not actuated, it will provide the signal to this particular coil. Okay, so it will be operated. So both 0, you will get the signal from both the switches. If it is any of the switch is 1, that means what? It will be open, but then also you will get the input from the another switch. And when both the switch is actuated, that means what? This both switches will be open circuited and no current will be there into the output coil. So your output will be 0. So this way you can develop a different kinds of circuits. Same way for the NOR, what we'll do? We'll just take this normally connected switches in a series and the output. So this way you can design this NOR output. And same way the XOR output. So XOR output will be depends on what? One is connected, one is not connected. So simple, you required one open switch, one closed switch, and that will be parallel with this closed switch and this open switch. Okay, so this way you will get the output. Okay, so if both open and both close, you will not get the output. So this way you can design a different logic gates. Okay, same way you can design any of the Boolean expressions also. Okay, because we know how to design logic gates, then you can design a Boolean expressions also. Okay, now let's say next thing, what happened in a simple circuit when you provide a switch with output. What happened? When you press the switch, it will remain off, and when you just don't actuate that switch, then what happened? Your output will be not there. Okay, so if we have a push button switch, then what happened? You have to push that switch till you want to operate the device. Okay, but if you don't want to do that, then you have to use this latching concept. So the latching is nothing but what? We are just using contact of this output in parallel with your switch. So what happened? This is your input switch 1, it's a push button, as well as this B is also a push button, but it is normally connected. So what we'll do, when we press this push button switch A, what happened? The connection will be there and your current will flow from here to here. Now what happened? This output is operated, so that means this particular output related switch is also operated. So that means again you will have a current from here. Okay, now when you just remove this pushing of this switch A, what happened? This current flow will be not there, but you will get continuously current flow from here, so it will remain on. Okay, so that's called a latching. So once you push the switch and if you release it, you will get the supply continuously if you design this type of latching. And if you want to break the latching, what you have to do, you have to press this switch B. So once you press the switch B, what happen, your connection will be disconnected and your latching will be breaked. So this latching concept will use mostly in your automation, okay, for doing the work, okay, because what we'll do, we'll just sense one time and then after it will be operated, okay. So once you sense anything, something like over there in the video we have seen that that block will be sensed, then after it will be moved further for the other operation. So once that block will be sensed, what you will do, you will just start that conveyor belt, so it will be moved, okay, till the next sensor will detect it, okay. So this way this latching will perform, okay. These are the applications, okay, different kinds of applications that you can develop, okay. So we'll see one or two applications related to this PLC automation, and then we'll conclude, okay, this session, because we'll have a shortage of time, okay. So one of the application is nothing but what, let's say on a conveyor belt, a bottle filling plant is there. So the bottle filling plant, you must require that bottle should be standing. So any of the bottle which is not standing, okay, then you have to remove that bottle from that particular conveyor belt. So over there they'll use what, two sensors, okay, and that will detect whether the bottle is standing or not. So if your both sensors will detect it, what you will do, you'll just pass that bottle. And if your one of the sensor is not detected, then what you have to do, you have to just start a mechanism which will push your bottle to this particular tray, which is over there at the downside. So it will be removed from the conveyor belt. So if this type of mechanism you want, then what you have to do, you have to sense this X0, okay. So if X0 is there, so X0 is nothing but one of our input, so we are representing it by this switch. So X0 is there, okay. If it is detected, and again if your X1 is detected, then what you have to do, you have to start the conveyor belt. So this is the output for conveyor belt, okay. This is the output of conveyor belt. So when X1 and X2 both are detected, your conveyor belt should be start, okay. So it will be moved continuously. And when it is X1 is not detected, okay, that means your X0 is detected but X1 is not detected, okay, then what you have to do, you have to stop the conveyor belt, as well as you have to stop the conveyor belt, as well as what you have to do, you have to start the pushing mechanism. You have to start the pushing mechanism. So this is nothing but, you can say, the coil related to conveyor belt starting, start, and this one is a coil related to conveyor belt stop, okay. And this is coil related to starting a pushing mechanism, okay. So this way you can develop your automation circuits, okay. So once you just design this particular ladder diagram, and if you fetch this ladder diagram in your PLC, then your PLC will work according to that, simple, okay. Whatever we have seen in that particular video, okay. Now this is a staircase related wiring, so it will be something like this. When the both switches it is actuated, your lamp will be on, and when both switches is not actuated, your lamp will be in a off. Not actuated, then also means in a same position your bulb or lamp will be on, and if it is in a reverse position, your lamp should be off. So that can be done by this way, okay. Now third application, let's say it's a fire safety related, sensors are there, okay. So they have written, if only one sensor is detected, means what, do nothing with that. If two sensors are detected, then you just operate a pilot light, okay. Means it will just give you the indication that something wrong in that particular industry, okay. If three switches are sensors are detected, then what you have to do, you have to trigger an alarm, okay, or a siren, you can say. And when all four sensors are detected, what you have to do, you have to on that alarm as well as that light, and you have to send a signal to a particular fire department that will just come and rescue that all peoples from that particular factory. So if you want to design that thing, then what you have to do, your sensor 1 is there. With that, you have to connect sensor 2. So this is sensor 1, this is sensor 2, and when it is single detected, you don't have to do anything. But when two sensors are detected, what you have to do, you have to start that LED. So this is nothing but your red LED. Okay, so it will be operated. Okay, when it is detected 3, so what you have to do, either you can take from here, okay, and you can connect the third. Okay, so if it is detected third sensor also, what you have to do, you have to operate your particularly alarm, or you can say siren. Okay, okay, and if the fourth also detected, what you have to do, you have to send the signal to fire department. So this signal will be sent to fire department. So this way you can design. So when 3 sensors are detected, your LED should be on as well as your sensor should be on. So this same thing will be operated. And if four all 4 sensors are detected, what we have to do, you have to start LED as well as siren, as well as you have to send the fire alarm. Okay, so this way you can develop a different kind of circuits. Okay, so then after this SCADA system is there. So this is the overview of this SCADA system. That SCADA system is nothing but supervisory control data acquisition system, which having computers as well as network data communications and GUI interface for the operation, and as well as it's having a PLCs for the controls. Okay, so that will be equipped in any industry for the automation purpose. Okay, and then after we are having the sensors, but due to lack of time, will not go deeper inside that, because the different types of sensors are there. Okay, so sensors are based on the analog and digital as well as scalars and vectors. Okay, so these are the different kinds of sensors. Okay, digital sensors, that are door entry sensors, smoke sensors, capacitive, motion sensors. Okay, you all know over about that. These are the types of sensors. But whatever we are using in our industrial automations, that are nothing but this mainly 5 sensors: inductive, magnetic, capacitive, ultrasonic, and photoelectrics. So when you go for industrial automation, these are the different sensors that will be used. Okay, inductive sensors will detect your, you can say, metallic devices or metallic part. Okay, then it will be based on the electromagnetic things. Okay, then magnetic sensor will be detect your magnetic material, this. Okay, and your capacitive sensor will detect any kind of materials. આપણી જે touch screen હોય છે, mobile touch screen is also a capacitive sensors, you can say. Okay, ultrasonic is used for the distance measurement. Okay, and photoelectric will be used for the what, any device or anything will be in between your transmitter and receiver, so to detect the devices if it is there or not. Okay, so these are the different types of sensors, its sensing range, and a different kinds of applications, and which kind of materials it can sense. So these are the different kinds of materials that can be sensed by a different kinds of sensors. Okay, so thank you very much. I will just conclude this session over here. Okay, and as madam told that our team has designed one of the course related to industrial automation with PLC, so that you can opt from this website. It's free of cost. You can complete that course and you can get a certificate. Okay, any further queries or uh, questions if you want to post, then you can use this email ID or number. Okay, so we'll conclude this session over here, and if any questions anyone have, then they can ask. So over to madam.
Thank you so much for this, for your valuable time. Actually, we had a question like, what are the some risks associated with automated testing? Like, is there any risk or something?
Hello. Sorry, but your voice is
Yes, sir.
breaking. You
Hello.
can repeat it.
Yes, sir. Is there any risk associated with this automated testing?
Raise. Are you talking about raise?
No, sir. Risk.
Risk. Okay. Risk. Oh, I got. Yeah. So risk related to automation is nothing but what? Just we are having risk of that our job will be in a problem, you can say. But if you learn, if we apply this automation properly, and if you learn different kinds of technologies related to this automation, then you will get a more job over there. I don't think so that risk is there, okay, because all the things will be operated based on sensors. So any harm related to that particular human interference between them, then you can avoid that thing, okay. So I don't think so that risk will be there, but yes, one risk related to the job securities, okay. So for that I will play one more video at the last, so you can understand that what are the benefit of that industrial automations, and it is from Bangalore only. Anyone else a question? Yeah, yeah, when you apply automation, it's very good, and it will obviously improve your life, okay. I remember one of the ad in which when that particular person is coming from the office, and it's reaching to its home, before that it will just start in between, it just start its home AC. So what happened, it's a summer time, so when it will that particular person will reach to the home, its home will be in a condition where it can stay, okay. So it will provide you can say benefit, or it will change the life when you use this automation. So features are nothing but when you going to design any automation circuit, then as I told you, obviously first thing will be the cost, okay. Depending on the cost, you have to find out whether which kind of devices you will use in that particular automation, okay. And then after, you have to go for the particularly input output related, okay, that how much input and output you requires, because always the cost will affect on that particular thing, okay. When you increase input outputs, your cost will be increasing, because each and every modules will be cost around, I think so, 2 to 5,000 rupees. So in that you can say in one module you are having 8 input outputs. It depends on your requirement. Different modules will have a different prices from the ranging of 2,000 to 5,000. Anyone else? Questions?
No, sir. It's clear. Thank you so much for your valuable time. And we had a great meet on basic industrial automation. Looking for more such meetings. Thank you so much, sir, once again. And I would also like to thank all the HODs, faculties, and the principal for joining with us. Thank you so much, everyone.
Okay, thank you very much. I just want to play a last video, okay, that is related to this automation in India. So with that particular video, we'll just conclude this session.
Okay, sir. Sure.
एशिया के सिलिकॉन वैली कहे जाने वाले शहर बेंगलुरु में बॉश इंडिया का हेडक्वार्टर। कंपनी में 31,000 कर्मचारी हैं और कार्ड पंच करते ही उन्हें पता चल जाता है कि आज उन्हें किस स्टेशन पर क्या करना है।
इसी वजह से हमको थोड़ा जो भी लॉसेस होते हैं, ऑर्गेनाइजेशन लॉस बोलते हैं उसको, क्योंकि मैन पावर नहीं है, रिसोर्स नहीं है, ये सभी हम ठीक से अलोकेट कर सकते हैं। इससे बहुत बढ़िया बेनिफिट मिला है हमारे लिए। ये जो भी हमको लगता था कि मैनुअल ट्रैकिंग करता था वो पूरा एलिमिनेट होके ये सिस्टम ट्रैकिंग हो गया।
इस प्लांट में अंतर्राष्ट्रीय बाजार के लिए कई प्रोडक्ट्स बनते हैं। इंडस्ट्री 4.0 वाले इस प्लांट में ज्यादातर वक्त मशीनें खुद एक दूसरे से संवाद करती हैं और मुश्किल काम को बिना थके लगातार करती हैं। इससे कर्मचारियों को काफी राहत मिली है।
ये तकरीबन 4-4 केजी वेट करता है। उसका तकरीबन उसका मतलब है 8 केजी हमारा अफसोस के एक लोड और अनलोड करना पड़ेगा। एक शिफ्ट में तकरीबन 8 घंटे में उनको 1600 बार उठा के लोड करके अनलोड करना है। ये उसके बाद उनको स्टेशन के एक्टिविटीज भी देखना है। ये थोड़ा मुश्किल का काम है क्योंकि उनका शोल्डर तकरीबन 1 मीटर के तकरीबन हाइट पर लोड करना पड़ेगा। इसके लिए थोड़ा दिक्कत होती थी, उनका शोल्डर ड्रूपिंग होता था और जो भी स्टेशन में 2-3 स्टेशन में काम करते थे उनको थोड़ा हेजिटेशन था कैसे काम करेंगे। इसलिए हमने सोचा कि एक अच्छा सोल्यूशन निकाले।
लेकिन क्या ऐसे उपाय धीरे धीरे इंसान की नौकरियां खत्म करते जाएंगे? दावोस के वर्ल्ड इकोनॉमिक फोरम की एक बहस के मुताबिक आर्टिफिशियल इंटेलिजेंस भविष्य में 70% से ज्यादा रोजगार इंसान से छीन लेगी। मशीनों का आपसी संवाद निश्चित रूप से समाज के ताने बाने पर असर डालेगा। तो इस डिजिटल ट्रांसफॉर्मेशन के नुकसान को कैसे कम किया जाए?
इन इंडिया
भारत में इसकी वजह से शायद कुछ नौकरियां खत्म हो सकती हैं, लेकिन मुझे लगता है कि अगर हम ऐसा नहीं करेंगे तो निश्चित रूप से नौकरियां खत्म होंगी, क्योंकि हम प्रतिस्पर्धा में नहीं टिक पाएंगे। मुझे पूरा यकीन है कि अगर भारत में हमने इसे ठीक ढंग से लागू किया तो ये ज्यादा नौकरियां पैदा करेगा। बात सिर्फ ये है कि ये नई नौकरियां बिल्कुल अलग तरह की होंगी और हमें अपने लोगों को इस डिजिटल ट्रांसफॉर्मेशन के लिए तैयार करना होगा।
कंपनी की क्यू एकेडमी अपने कर्मचारियों को भविष्य के लिए तैयार करती है। यहाँ वर्चुअल रियलिटी स्टेशन और कई तरह के वर्कशॉप्स के जरिए कर्मचारियों को नए काम की ट्रेनिंग दी जाती है।
हमने डिफरेंट स्टेशन जो भी शॉप में चल रहा है उधर एक सिमुलेट किया है, एक्चुअली 1:1 किया है, ताकि जो भी एसोसिएट इधर आके एक हफ्ता ट्रेनिंग करेंगे कैसे हैंडल करना है, कैसे पार्ट को सेंसिटिवली लोड करना है, अनलोड करना है, क्या क्या पैरामीटर चेक करना है। इसकी वजह से उनका थोड़ा नॉलेज भी बढ़ेगा और जो भी स्किल उन्होंने नहीं किया होगा ये जगह आके वो स्किल डेवलपमेंट कर सकते हैं और उनको आसान हो जाएगा जो भी न्याय जाएगा उनको काम करना।
2021 तक पूरी तरह त्रुटिहीन होने का लक्ष्य, क्या इस मंजिल तक एक टेबल फैन के सहारे पहुंचा जा सकता है? एकेडमी में कर्मचारियों से इस पंखे को खोलकर दोबारा असेंबल करने को कहा जाता है। अंत में नतीजा परफेक्ट होना चाहिए। पंखे के नतीजे क्वालिटी कंट्रोल के बारे में अहम जानकारी देते हैं।
ये स्टेशन डिजाइन और स्टेशन की परफेक्टनेस बताता है। साथ ही कर्मचारी को जरूरी निर्देश मुहैया कराए जाते हैं। अगर वो स्टैंडर्ड के मुताबिक काम करेगा तो असेंबली प्रोसेस में कोई गलती नहीं होगी।
1760 से 1840 के बीच हुई औद्योगिक क्रांति के बाद अब उद्योग जगत इंडस्ट्री 4.0 के नाम से बड़ी करवट ले रहा है और उसके लिए बड़ी तैयारी की जरूरत है।
Okay, so that's it. Thank you very much to everyone.
Thank you so much, sir, for your time. And thank you, everybody. We should conclude our session here.
Thank you, madam.
Thank you so much, sir, for your time. And now here we end our meeting.